Okay, continuing to work with our basic frequency distribution table, let's take something that we looked at in Chapter 1, a very simple calculation, the summation of the raw scores for variable x. So this says, add up all your raw scores for variable x. Again, what students want to do is go 5 plus 4 plus 3 plus 2 plus 1 is 15. And say, well, the summation of x is 15s. No, this says sum up all the raw scores. If we just add these up, we've only added 5 scores. We already know there's 14 of them. We've omitted 9 scores. It's 5 plus 4 plus 4 plus 4 plus 3 plus 3 plus 3 plus 3 plus 3, right? So you can do it that way. You can, yeah, right on your fingers like I just did. You can do that. But there's a simpler and more reliable, better way to go. So all we need to do if we're working with this table, if we want to know what's the summation for the value of all the raw scores put together, is we can get the summation of the products of x times f. When we did this as an example in Chapter 1, we had an x and a y. Here's an x and an f, but it means the same thing. So we're going to get the products of x times f first. Doesn't matter if it's sigma fx or sigma xf, it doesn't matter which way you multiply numbers. So sometimes I write it with the f first, sometimes I write it with the x first. Doesn't make any difference at all. But first we've got to get these products, and then we'll sum all those products up. So I'm going to do a scratch work column here. Never, ever, ever put your scratch work in the official table. Never, never, never. This is a communication tool. This isn't built for showing your work, if you will. So we're going to keep that aside. So this says we're simply going to multiply the values across. 5 times 1 is 5. 4 times 3 is 12. 3 times 5, 2 times 3, 1 times 2. Now we've got all the products, and we simply sum all those products up. So 5 plus 12 plus 15 plus 6 plus 2. When you add all that together, you will learn what the summation of the raw scores for variable x is. And what you should get for that is 40. So I said before, make sure you're calculating along. Pause the video and work your calculator. Make sure you're getting the answers. Make sure you're understanding the flow. You can maybe just watch it through once, but you want to make sure you're practicing doing it so you can do it when you need to do it. So that's one thing we could do. What if instead we wanted to do another thing we looked at in Chapter 1? What if I instead want the summation of the squared raw scores? You might recall seeing that. It's going to be in a formula in a couple of chapters. So that's the kind of thing we might need to calculate out of a table. So again, stop and think about the order of operations. First thing that happens is exponents. So the first thing that happens here is we have to square all the x values. So again, let's do a little scratch work column for that. So 5 squared is 25. 4 squared, 16. 3 squared, 9. 2 squared is 4, and 1 squared is 1. Now, be careful. We want the summation of all the squared raw scores. So what we do not want to do is say 25 plus 16 plus 9 plus 4 plus 1. That'd be the same mistake for the last problem if we just added 5, 4, 3, 2, and 1 together. We'd be wrong. Because how many squared 4s are there? There's 3 of them. It's not 1 16, there's 3 16s in there. How many squared 3s are there? There's 5 of them. There's not 1 9, there's 5 9s. So once our data is in a frequency distribution table, you pretty much always need to work both the columns together. So in order to calculate this, we're going to need to do just basically a version of what we saw on the last one. In this case, I wrote the f first just because I think it looks better that way. But we still need to multiply the frequency values times the score values. In this case, the squared score values. So we need to put all of this together, make another little scratch work column here. So we don't need this column anymore, we need the squared columns. So the frequency times the squared value. So 1 times 25, 25. I'm going to need my calculator. One thing you do not have to be in this course is a human calculator. We have them in mechanical form. So let's see here. 16 times 3 gives us 48. Well, 9 times 5 is 45. 3 times 4 is 12. 2 times 1 is 2. One of the things I tell my classes is don't be afraid of using your calculator even for simple things. No one has to be a math savant here. Use your fingers if you need to, however you want to count it up. So now we have multiplied the frequencies times the squared values. And now we sum those up. So 25 plus 48 plus 45 plus 12 plus 2. And what you should get here is... Oops. Board rocking on me. 132 is what I'm trying to write there. Board shaking. 132. So if we add all these up, we get 132. Clearly a very different answer than if we had added there. So that is one of our basic ways of dealing with data to put it in a standard frequency distribution table. Now, before we move on from here, let's consider one more idea. Let's pretend for a moment, let's pretend that there were no 2's. If there were no 2's, we still have to include the value for 2. It was a possible score. It was something somebody could have gotten. What we don't want to do is this. Again, tables and graphs are communication tools. Typically, if you're doing this, you're not just doing it for yourself, you're doing it for some reader, for some audience, for some other person, so they can go, oh, and understand your data better. Well, what happens here, if you were sent this table, you looking at this online or in the book, you might have to ask yourself, well, what's going on here? Why is 2 not on the table? Does that mean there were no 2's? Or does that mean there's a typo and they forgot to put in how many 2's? We should never have our audience guessing what we meant in a table or a graph. So what we want to make sure we're doing is being very, very clear about it. And the way to do that is to include all the categories and simply indicate there were no 2's. And now there's no question. The reader of this table would know exactly what that meant. They wouldn't have to guess about it. So whenever we're missing a score, if you will, we don't delete it from the table. The same will be true of graphs in the next video. We don't just skip over it like that number doesn't exist. We include it and record it as the frequency of 0. So from here, what we're going to do is start expanding our table. We're going to start adding into our table a couple other useful columns. So we'll see you in the next video for that.